Hello everyone, in today's video we're going to cover geometric applications of exponents. Our learning target for today is I can simplify expressions to represent the area of a figure. In order to find the area of figures, we need to use their area formulas. Now in our diagrams below, we can see that we have four common figures and their formulas. The first figure we have is a right triangle. Area of a right triangle is 1/2 AB, where A and B stand for the legs of my right triangle. Remember, C is the hypotenuse, that's the longest side, so AB would be the shorter sides of my right triangle. Circle, the area formula for a circle is pi r squared, where r stands for the radius of my circle. A square, area equals s squared, where s is my side of a square. And then a rectangle, area equals lw, where L and W are the length and the width of the rectangle. Now looking at our sample problems, we're going to find the area in the simplest terms of each figure. Number one, we have a right triangle. I know this is a right triangle because my box tells me this angle is 90 degrees. So 10a squared would be my hypotenuse, where 4a squared b and 3ab are my legs. Now the formula for a right triangle is area is equal to 1/2 times my legs. So 1/2 times the legs of 4a squared b times 3ab would be the area. Now 1/2 times 4a squared b times 3ab. Here I can use my product rule of exponents. So I'll keep my 1/2 together and then I'll multiply the 4a squared b and the 3ab. So 4 times 3 is 12. A squared times a1 would be a3, and b times b is b squared. Now I can finish this by multiplying 1/2 and 12, which would give me 6, and then a3 b squared would stay the same. So my simplified expression for the area of this right triangle is 6a cubed b squared. So if I was given the values of a and b, I could easily find the area. That's what we're doing through these problems. We're just simplifying in simplest terms to quickly find the area if we were to be given the values. Number two, we have a circle. The radius here is 3xy cubed. I know the area of a circle is pi times r squared. So I'll have pi times the radius squared, which would be 3xy cubed all squared. I have 3xy cubed in parentheses because I can see that this is r squared, so I need to multiply the whole radius by itself. So if I multiply 3xy3 to the power of 2, this would be pi. I need to bring the 2 to the 3 to the x and to the power of 3. 3 squared would be 9, x1, x2, and then y3 would go to y6. So I'd have 9x squared y6 times pi. So if I just write this in better terms, I'd have 9 pi times x squared times y6. And this would be the area of my circle. Number three, a square with a side length of 12 x to the 7th y squared, all to the third power. I know a formula for square is side squared, so I want my simplified side and then square that. So here I have my side already to the third power, so I'm going to multiply everything by itself 3 times in order to simplify one side length. If I do that, I'd have 12 to the third power. I'd have x to the 7th to the third power, which is x to the 21st, and then a y squared to the third power, which is y to the 6th. So my simplified side is 12 to the third, x to the 21st, y to the 6th. Now I can plug it into my formula, where I'm now going to square 12 to the third, x to the 21st, and y to the 6th. If I do this, I'm going to multiply my side by itself. So I'd have 12 to the third to the second, which would be 12 to the 6th. X to the 21st squared would be x to the 42nd, and y to the 6th squared would be y to the 12th. So the area of a square with my side length of 12x to the 7th y squared all to the third power is 12 to the 6th, x to the 42nd, y to the 12th. And my last is a rectangle with side lengths 12x and 5x squared. I know area of a rectangle is length times width. So if I say my width is 5x squared and my length is 12x, I would have 12x times 5x squared. 12 times 5 is 60, and then x times x squared is x to the third. So the area of a rectangle with my side lengths is 60x cubed. In today's lesson, we learned to find the simplified expressions of geometric figures. We can use our exponent rules and area formulas. That's a wrap on today's video. We'll see you in the next one.